What if a polar bear lived in the Sahara? What if a camel lived in the Arctic? Two animals perfectly adapted to their environments. Swap them? Instant death. That's the theme of today's video. We're taking 20 animals and giving them features they were never meant to have, and we're going to explain exactly why they'd fail. What if a lion had zebra stripes? It can't hide anymore. What if a wolf had a giraffe's neck? It can't run. Every combination has a fatal flaw, and that's what makes this fascinating. Using artificial intelligence, we're showing you how these creatures might look if nature had made them different, and we're explaining why nature got it right the first time. What if a polar bear lived in the Sahara? On the surface, it sounds like an epic survival story, a massive white predator roaming the golden dunes. But here's the brutal truth. It would be dead within hours. Polar bears are built for one thing: extreme cold. They have thick layers of blubber and dense fur that trap heat so effectively they actually overheat at temperatures above 10 degrees Celsius. Now imagine that bear in the Sahara, where daytime temperatures hit 50 degrees. It wouldn't just be uncomfortable, it would suffer fatal heat stroke almost instantly. And then there's the food problem. Polar bears hunt seals from sea ice. In the desert, there's no ice, no seals, and no water. They'd starve while surrounded by sand. Their white fur, perfect camouflage in snow, would make them glow like a beacon against brown dunes. Prey would see them coming from miles away. So, a polar bear in the Sahara isn't an adventurer. It's a walking corpse. Evolution spent millions of years perfecting this animal for the Arctic. The desert is its worst nightmare. But what if we took another extreme animal and swapped its habitat? Let's find out. What if a camel lived in the Arctic? At first glance, it makes perfect sense. Camels are famous for surviving extreme conditions: heat, drought, long journeys without water. Surely they could handle the cold too, right? Wrong. Completely wrong. Camels are built for desert heat, not freezing tundra. Their fur is thin compared to Arctic mammals. No dense undercoat, no thick layer of blubber for insulation. In the Arctic, temperatures drop to minus 40 degrees Celsius. A camel would freeze to death within a single day. Its body simply isn't designed to retain heat in those conditions. And then there are the feet. Camels have wide, padded feet that spread their weight perfectly on sand. On ice and snow, they'd slip and slide constantly. They wouldn't be able to walk, let alone find food. Speaking of food, camels eat thorny desert plants. In the Arctic, there's nothing but frozen ground and moss. A camel in the Arctic is a disaster waiting to happen. It's the perfect example of why animals belong where evolution placed them. But what if we gave wings to an animal that lost them? What if a penguin could fly like a puffin? Both are seabirds. Both spend time in the water. Both look like they should be able to take to the skies. So why can't penguins fly? The answer lies in their wings. Penguins have evolved for swimming, not flying. Their wing bones are fused and flattened into flippers, perfect for propelling through water, but completely useless for generating lift. A puffin's wings are hollow and lightweight, designed for flight. A penguin's wings are dense and heavy. If a penguin tried to fly, it would flap uselessly and fall straight back down. The energy cost would be enormous. Penguins would need to burn massive calories just to get a few feet off the ground. Their bodies are too heavy, their wings are too small, and their chest muscles aren't built for sustained flapping. Evolution forced penguins to choose: be great swimmers or great flyers. They chose swimming. Giving them flight would ruin everything they're good at. But what if we took camouflage away from a predator? What if a lion had zebra stripes? It looks cool. It looks exotic. It would definitely stand out in a crowd. And that's exactly the problem. Lions are ambush predators. Their success depends on remaining hidden until the last possible moment. Their tawny brown coats blend perfectly with the golden grass of the African savanna. They become nearly invisible to prey. Zebra stripes would destroy that camouflage completely. A striped lion wouldn't be able to stalk prey. Wildebeest and zebras would spot it from a mile away. Hunting success would plummet from 25% to nearly zero. The lion would starve while surrounded by food it couldn't catch. And it gets worse. Those stripes might also confuse other lions in the pride, disrupting pack coordination during hunts. Lions rely on visual communication. Adding stripes would mess with their ability to recognize each other. A zebra-striped lion is a beautiful failure. Nature knows best. But what if we swapped teeth between a herbivore and a predator? What if a cow had shark teeth? Imagine a gentle cow grazing in a field, and then it opens its mouth to reveal rows of razor-sharp, serrated teeth. Terrifying, right? But here's the problem. Those teeth would be completely useless. Cows are ruminants. Their digestive system is built for processing grass and plant material. They need flat, grinding molars to chew their food into a pulp that can be fermented in their stomachs. Shark teeth are sharp and curved, designed for gripping and tearing flesh, not grinding plants. A cow with shark teeth couldn't chew grass properly. The food would pass through undigested, and the cow would starve despite eating constantly. It's like trying to cut a steak with a butter knife, the wrong tool for the job. And that's not even mentioning the fact that shark teeth are constantly replaced throughout their lives. They shed and regrow. Cows only have one set of teeth. Adding shark teeth to a cow would be a biological disaster. A shark-toothed cow is scary, sure, but it's also doomed. But what if we stretched a wolf's neck? What if a wolf had a giraffe's neck? A wolf that could see over tall grass and spot prey from a distance. Sounds like the ultimate hunting machine, right? Wrong. It's a disaster waiting to happen. Wolves are built for running and pouncing. Their bodies are compact, muscular, and perfectly balanced for long-distance endurance hunting. A giraffe's neck is long, heavy, and designed for reaching high tree branches, not chasing prey across open terrain. Add that neck to a wolf and you completely destroy its center of gravity. The wolf wouldn't be able to run properly. It would be constantly off balance, its head swaying with every stride. It couldn't turn quickly, it couldn't pounce accurately, and it couldn't coordinate with its pack. And then there's the hunting itself. Wolves grab prey with their powerful jaws. A long neck would make it harder to aim and bite. The prey would escape while the wolf struggled to coordinate its head. A wolf with a giraffe's neck is a wolf that can't hunt. But what if we gave a slow animal a fast metabolism? What if a panda had a cheetah's metabolism? A fast, energetic panda that races through the bamboo forest at lightning speed. Sounds incredible, right? Here's the problem. Pandas eat bamboo, and bamboo is one of the lowest calorie foods on the planet, only 20 calories per 100 grams. Pandas have evolved to conserve energy. They move slowly, sleep 10 hours a day, and have a digestive system that extracts every possible calorie from their bamboo diet. A cheetah's metabolism is the exact opposite. It burns massive amounts of energy in seconds during high-speed sprints. If a panda had a cheetah's metabolism, it would need to eat 50 kilograms of bamboo every single day just to survive. That's twice what a normal panda eats. Even then, it would struggle to get enough calories. It would spend every waking moment eating and still starve. Pandas are slow for a reason. Evolution made them that way because bamboo can't support a fast metabolism. A panda with a cheetah's metabolism isn't a super panda. It's a starved panda. But what if we gave a tiny bird a massive beak? What if a hummingbird had an eagle's beak? A fierce little warrior with a massive hooked beak. Sounds like a terrifying predator, but physics says no. Hummingbirds are the smallest birds in the world, weighing just a few grams. Their entire body is built around one thing: flight. Their wings beat up to 80 times per second, and their tiny bodies are incredibly lightweight. They need long, thin, needle-like beaks to reach deep into flowers for nectar. An eagle's beak is massive, heavy, and curved, designed for tearing meat from carcasses. Add that to a hummingbird, and the weight alone would make flight impossible. The hummingbird's tiny chest muscles simply can't lift that kind of weight. And even if it could fly, what would it do with that beak? Hummingbirds drink nectar. You can't drink nectar with a beak built for ripping flesh. The beak would be completely useless for the hummingbird's lifestyle. A hummingbird with an eagle's beak would plummet from the sky within seconds. But what if we gave legs to an animal that lost them? What if a snake had legs? It sounds like a throwback to their ancient ancestors, lizards that eventually lost their limbs. But giving a snake legs would be a catastrophic mistake. Snakes are perfectly adapted for slithering. Their ribs and belly scales work together in a complex wave-like motion that allows them to move across almost any surface. Their bodies are long, flexible, and streamlined. Adding legs would completely disrupt that movement. Legs would get in the way during constriction. Snakes wrap their bodies around prey to suffocate them. Legs would tangle and make the process impossible. And swallowing, snakes have flexible jaws that expand to swallow prey whole. Legs would get tangled in the process, choking the snake. Snakes lost their legs for a reason. 100 million years of evolution proved that legs were more of a hindrance than a help. Legs would make snakes slower, less agile, and less effective predators. A snake with legs isn't an upgrade, it's a downgrade. But what if we gave a slow animal the legs of a fast one? What if a tortoise had kangaroo legs? A hopping tortoise. It sounds hilarious, but it also sounds incredibly painful, because that shell would shatter instantly. Kangaroos have powerful hind legs with elastic tendons that store energy like springs. Their entire body is built for hopping, lightweight, balanced, and designed to absorb the shock of repeated landings. Tortoises are the exact opposite, heavy, rigid, and encased in a shell that's fused to their skeleton. If a tortoise tried to hop like a kangaroo, the impact of each landing would send shock waves through its shell. The shell would crack. The legs would snap under the immense weight. The tortoise would be crippled within seconds. Tortoises are built for slow, steady movement on solid ground. Their legs are short and sturdy, perfect for supporting their heavy bodies. Hopping is an efficient form of movement for lightweight marsupials, not armored reptiles. A kangaroo tortoise is a broken mess. Sometimes slower is better. But what if we took away an animal's camouflage? What if a penguin could change color? It sounds like a cool superpower, but for a penguin, it's a death sentence. Penguins have a specific color pattern called countershading. Their backs are dark, usually black or blue-gray, and their bellies are white. This pattern provides perfect camouflage in the water. From above, the dark back blends with the dark ocean depths. From below, the white belly blends with the bright sky. If a penguin could change color, it would lose that consistent camouflage. It might change to the wrong color at the wrong time, making it visible to predators like leopard seals and orcas. One wrong move and it's dinner. And there's another problem. Chameleons change color for temperature regulation and mood, not just camouflage. A penguin already has perfect temperature regulation through its feathers and blubber. Adding color change would be an unnecessary and dangerous feature. What if a cheetah had a turtle shell? On paper, it sounds like a great idea. A cheetah is fast but vulnerable. A turtle shell provides perfect protection. Combine them and you get the ultimate survivor, right? Wrong. A turtle shell on a cheetah would destroy everything that makes it special. A cheetah's spine is incredibly flexible. It acts like a spring during the sprint, compressing and expanding to launch the cheetah forward at 120 kilometers per hour. A turtle shell is fused to the spine in turtles. Attaching one to a cheetah would completely lock up its spine. No flexibility means no sprint. No sprint means no food. A cheetah without speed is a dead cheetah. And that's not all. The shell would add massive weight, making the cheetah slower and clumsier. It couldn't turn quickly, couldn't accelerate properly, and couldn't chase its prey. A turtle-shelled cheetah is slower, weaker, and less agile. Evolution gave cheetahs their flexible spines for a reason. Speed is their only weapon. But what if we gave heavy legs to a heavy animal? What if a hippo had ostrich legs? Imagine the fastest bird's legs on one of the heaviest land animals. It sounds like a speed demon, a hippo that could outrun everything. But here's the problem. Ostriches have hollow, lightweight bones, perfect for speed, but extremely fragile. Hippos weigh up to 1,500 kilograms. Those hollow bones would shatter instantly under that kind of weight. The hippo wouldn't just be slow, it would collapse immediately. Its legs would snap, its body would crash to the ground, and it would never walk again. It's basic physics. Hollow bones can't support massive weight, and even if the bones somehow survived, the hippo's body isn't built for that kind of movement. Hippos are designed for wading in water and charging on land. Ostrich legs are built for long-distance running. The muscle structure, the joints, the tendons, none of it would work. A hippo with ostrich legs is a broken animal. Evolution gave hippos their sturdy, short legs for a reason, to support their massive bodies. But what if we gave a predator the wrong teeth? What if a shark had human teeth? Imagine a great white shark swimming toward you, opening its massive jaws and revealing a perfect set of human molars. Terrifying, yes. Effective? Absolutely not. Sharks have rows of razor-sharp serrated teeth designed for one thing: gripping and tearing flesh. Their teeth are constantly replaced throughout their lives, shedding and regrowing in a conveyor belt system. Human teeth are fixed, non-replaceable, and designed for chewing plants and cooked meat. If a shark had human teeth, it couldn't grip slippery fish. It couldn't tear through blubber. It couldn't hold on to struggling prey. The teeth would be completely useless for its hunting style. And then there's the environment. Human teeth rot in saltwater within weeks. Sharks swim in saltwater their entire lives. A shark with human teeth would lose its teeth rapidly and have no way to regrow them. A shark with human teeth is a shark that can't eat. Evolution gave sharks their razor-sharp teeth for a reason. But what if we gave a sprinter the stamina of a marathon runner? What if a cheetah had a horse's stamina? A cheetah that could run for hours instead of seconds. The ultimate pursuit predator, never stopping, never giving up. Sounds unstoppable, right? But here's the brutal truth. A cheetah with horse stamina would overheat and die. Cheetahs are sprinters. Their bodies are designed for short, explosive bursts of speed. During a chase, their muscles generate enormous amounts of heat. Their body temperature rises dangerously high. After 30 seconds, they have to stop or they'll suffer fatal heat stroke. Horses, on the other hand, have evolved for endurance. Their muscles are efficient, their cooling systems are advanced, and their bodies are built to run for hours without overheating. If a cheetah suddenly had horse stamina, it would try to run for hours. Its body would overheat within minutes. It would collapse and die. Sprint muscles can't simply become endurance muscles. They're fundamentally different. A cheetah with horse stamina is a dead cheetah. Evolution gave cheetahs their sprinter's body for a reason. What if a gorilla had an armadillo's armor? An armored ape, tough, invincible, unstoppable, but it would also be unable to climb, swing, or feed itself. Gorillas are agile climbers. Their long, powerful arms are designed for swinging through trees and gathering food. An armadillo's shell is heavy, rigid, and restricts movement. Add that shell to a gorilla and you've taken away its most important tools. The gorilla wouldn't be able to climb, its arms would be weighed down, its movements would be sluggish, and it would struggle to reach food in the trees. And on the ground, the shell would make it difficult to bend, stretch, and move freely. Gorillas also use their hands for foraging. They pick fruits, dig for roots, and use tools. A shell would restrict their reach and make these tasks nearly impossible. An armored gorilla is a gorilla that can't live its life. Evolution gave gorillas their powerful arms for a reason. Not for armor, but for climbing and eating. But what if we made an animal from fire? What if a penguin was made of lava? It sounds like something from a fantasy video game, a creature of fire and molten rock, standing defiant in the frozen wasteland. But here's the thing, it would make zero biological sense. Lava is 1,200 degrees Celsius. Penguins are insulated for freezing water. Their feathers and blubber are designed to keep cold out and heat in. A lava penguin would melt the ice beneath it instantly. It would sink into the ocean, and the water would cause the lava to solidify, trapping it in stone. And then there's the whole problem of life. Lava isn't alive. It has no cells, no DNA, no organs, no digestive system, no nervous system. A lava penguin wouldn't eat, it wouldn't reproduce, and it wouldn't have instincts. It's not a creature, it's a rock with a shape. A lava penguin is pure fantasy, and while it looks cool, it would be completely useless in any real-world ecosystem. But what if we gave one bird the speed of another? What if an eagle had a falcon's dive speed? Both are birds of prey. Both hunt from the sky. Combining their abilities should create the ultimate aerial predator, right? But physics has other plans. Eagles have large, broad wings designed for soaring and gliding. They're powerful birds, but they're built for strength, not speed. Falcons have pointed, swept-back wings built for one thing, diving at speeds of up to 390 kilometers per hour. If an eagle tried to dive like a falcon, its wing bones would snap under the extreme G-forces. Eagles simply aren't built for that kind of aerodynamic stress. Their bodies would be torn apart mid-dive. And even if the wings somehow survived, the eagle's eyes aren't designed for that speed. Falcons have a special bony projection in their nostrils to guide airflow at high speeds. Eagles don't have that. They'd struggle to breathe and see clearly during the dive. An eagle with a falcon's dive speed is a broken bird. Evolution gave each species its own hunting style for a reason. But what if we put a shell on a predator that needs flexibility? What if a crocodile had a turtle's shell? Both are reptiles. Both have armor. Combining them should create the ultimate armored predator, right? Unfortunately, that shell would cost the crocodile its deadliest weapon. Crocodiles rely on full-body flexibility to perform the death roll, a spinning maneuver that drowns prey and tears off chunks of flesh. That spinning requires a flexible spine. A turtle shell is fused to the spine, completely restricting movement. Put a shell on a crocodile and it can't death roll. It can't spin. It can't drown its prey effectively. Its primary hunting technique would become impossible. And that's not all. The shell would make the crocodile slower in water, less agile, and less capable of ambushing prey. Crocodiles rely on surprise attacks. A slow, clunky crocodile is a hungry crocodile. A shelled crocodile is a failure. Evolution gave crocodiles their tough, scaly skin for a reason. It provides protection without restricting their flexibility. But what if we gave a horn to an animal that already has tusks? What if an elephant had a rhino's horn? Two of the largest land animals combined, the elephant's size with the rhino's weapon. Sounds like the ultimate tank, right? But here's the problem. An elephant's trunk is its most important tool. It uses its trunk to eat, drink, breathe, smell, and communicate. Adding a horn in the middle of its face would block its field of vision and make trunk movement awkward. The horn would get in the way every time the elephant tried to reach for food or water. It would bump into the trunk, making feeding slower and less efficient. And elephants already have tusks. They don't need another weapon. Elephants also rely on their trunks for social communication, touching, hugging, and playing. A horn would make those interactions awkward and potentially harmful. An elephant with a rhino's horn is a confused elephant. Evolution gave elephants their tusks and trunks for a reason. They work perfectly together. And there you have it. 20 animals that AI created and nature immediately rejected. So the next time you see a bizarre animal mashup online, remember, there's a reason nature didn't make it that way. If you enjoyed this video, hit that like button and subscribe for more wild science experiments. And let me know in the comments, what other animal mashups should AI create next?